Good day, everyone. Today we shall be considering logarithm theory. Under this study, we shall be considering conversion from logarithmic form to index form and vice versa, and two logarithmic equation leading to quadratic equation with relevant exercises and answers. So conversion from index form to logarithmic form and then vice versa. From our definition of logarithm, we said the log of p to base a is equal to x. Now this is simply saying that the index of a, which is x, would give us p. That's what we said when we defined logarithm. And so from this now, we can see that we could convert from logarithmic form to the index form. So let's see some examples now on just converting from logarithmic form to index form. And so we're looking at first one, log 81 to base 3 equal to 4. And this is quite an easy one. It's just the index form is simply 3 raised to power 4 is equal to 81. I have a way of doing this. Just say let the base of the logarithm should come and carry the result of the logarithm. That's just all. So 3 raised to power 4 equal to 81. So that goes for the b likewise. For the b, we have log 256 now. 4 equal to 4. Simply this 4 here, the base comes to carry this 4 as its index. So that is 4 raised to power 4 is equal to 256. You can take that to the c likewise. We know we have log 216 base 6 being equal to 3. And so we'll have this 6 raised to power 3. That is 6 raised to power 3 is equal to 216. So quite an easy one. Let's take example 2, which is converting from index form now to logarithmic form. So for this now, we have 3 raised to power 4 equal to 81. So this simply will be log 81 to base 3, just like the opposite of what we did in the previous example, equal to 4. And quite an easy one actually. For the b, we have 27 raised to power 1 over 3 being equal to 3. And so all we have is log, we have 3 base 1 over 3 is equal to 27. For the c now, we have log 1 base 5 is equal to 0. Okay, sorry, I'm not even writing the question any longer. Don't mind me. So we have 5 raised to power 0 being equal to 1. So we would have log 1 base 5 equals 0. And so that's that about that. And so from now, we want to see. So next, we are looking at logarithmic equation leading to quadratic equation. So here we are saying solve the following logarithmic equation. Log x squared plus 5x plus 10 equal to 4 to base 2. But the first thing to do is to convert to index form. Right here we would have x squared plus 5x plus 10, 5x plus 10 being equal to 2 raised to power 4. And 2 raised to power 4 is 16. So then we have x squared plus 5x plus 10 and minus 16 equal to 0. And then this becomes x squared plus 5x minus 6 equal to 0. This is a quadratic equation, and then we can solve it by factorization. And so this will simply give us x squared plus 6x minus x minus 6 being equal to 0. Trying to factorize. S being common plus 6. Then minus 1 being common in the next two terms, which is x plus 1 plus 6 now being equal to 0. So we would have x plus 6 and x minus 1 being equal to 0. So x plus 6 is equal to 0, or x minus 1 is equal to 0. So we have x equal to 6 minus 6, or x equal to 1. And so for the second one now, we go about the second question. And so for this same step, convert to index form. So we have x squared minus 3x plus 12 is equal to 10 raised to power 1. And so we would have x squared minus 3x plus 12 and then minus 10 being equal to 0 now. And then this will give us x squared minus 3x plus 2 being equal to 0. This is a trinomial, so this will be x squared minus 2x, trying to make the terms 4 so that we can factorize, plus 2. So we have 4 terms now, and so we can factorize now. X minus 2 minus 1 into x again minus 2 being equal to 0. So we have x minus 2, x minus 1 being equal to 0. We have x minus 2 being equal to 0, or x minus 1 being equal to 0. So we have x being equal to plus 2, which is 2, or x being equal to 1. So you can try the following exercises now. So try these exercises now.